What is up, everybody? Welcome to the Ham Radio Crash Course. Welcome to Saturday. How y'all doing? If you getting hit by the sun, has the sun been beating up on you and your ham radio activities? Well, fear not, because we're going to talk about Coax. Maybe it's a good day to learn something and get off the radio for a second. Anyway, enjoy the memes. We're going to get things started real soon. As a reminder, this is a Patron Picks episode, catching up on all that travel I did last month. And just want to say thanks again to all the support I get over on Patreon. Thanks a lot. You're gonna laugh, Tom, but stick around. That's a very funny quote you just did. All right. Hey, how's it going, everybody? Appreciate you clicking on the Ham Radio Crash Course today. Again, patron pick. So we're going to talk about coax, and not just like go buy this type of coax, but we're going to talk about why and the important considerations. So I got a lot of links. There's so many links in the video description just from all the things to want to hit there. There we go. Go check out hamtactical.com if you'd like to get some Ham Radio Crash Course merch. It helps to support this video channel, of course, but also our podcast that I do with my wife, the Ham Radio Crash Course podcast. Yes, yay, verily. As far as getting out and making it happen, shout out to Ham Jazz. Made a contact with him earlier, VA7BIX. He was on a boat, like a canoe, that he had rigged up an HF antenna and had radials in the water, and he was on salt water. He killed it. Oh, he's in the chat. What's up, man? He was doing a great job. It was really cool making a contact with him, and he was getting a pile up on just this horrible, horrible day of ham radio with all the solar activity we've had. So, hey, just goes to show you, you can still make it happen. Make sure you go give him some love. In fact, I'll drop the video. I have a contact with him in there that he got live. I just wasn't able to queue it up before the video got started, but cheers, mate. Appreciate you. All right, next, if you are going to Dayton Hamvention, here's the Meshtastic channels that I'll be on. This leaves the default basic channel and adds another like side chat encrypted channel. Not that we're going to do any encrypted type stuff, but it's just a way for us to get off the main chat if there's a ton of people on Meshtastic. So there it is. If you want to go back, pause the video, catch up with it, that's all you got to do is point your Meshtastic app at it and go bink, and it'll reload all the channels for you. All right, I added a couple of things here. So we got Coax Essentials and Meshtastic gear. So the Meshtastic stuff, that'll cover you if you want to get up and running with a Heltec V3 and some of the stuff you might need if you want to 3D print a case. And then Coax Essentials are some of the things I'll be talking about on the live stream, but a lot of it's tools too. Very good, very good. We do have a lot to get into, so I figure we just mow right into this. And my slides are all screwed up too again, so let's make sure we're there. Okay, we good? Are we good there, slides? Are you good? I hope so, because I got to do my actual presentation here. There you go. All right. So selecting the right coax. I only have a couple of slides I want to cover, and really it's just to kind of set the stage a little bit and kind of change some mindset. So history of coax, a very short history. Coax was first used in 1858. It was first patented, British patent 1407. In 1880. Yep, there you go. Check Wikipedia for that. Its initial use in the transatlantic transmission lines for like telegraph, right? Telegraphy. 50 ohm standard was generally believed to happen in 1929 in Bell Labs when testing a 4 megahertz wide signal that they needed to use for a pretty wide signal opportunity. So yeah, okay. Coax been around forever, right? It's a shield that has a dielectric in between the pin, and that's kind of your positive and negative, and that's just a simple way of me remembering it. And it's got a jacket on the outside that helps it be weather resistant. So in a word, the reason why we kind of like coax and why we use it is because it's convenient, right? It's a lot easier to be manipulating a spool of wire than it is running around with something like twin lead, because twin lead is also an effective feed line, but it has its own characteristics, and some of them are undesirable, right? So just a brief mention of this, coax became popular and kind of became commonplace because it provided things, although there are downsides to coax. that twin lead couldn't do. So if you ever use twin lead, which that's a doublet antenna right there, it can't really be by metallic objects. And yeah, you see that like that's a metal pavilion. And we're close to it, and it actually did affect the characteristic impedance of the feed line and did mess with actually using some of the bands. You cannot bury twin lead generally, and it's kind of inconvenient to go inside and outside of buildings with. A lot of people will switch to coax to go inside a building or outside of a building. And coax being shielded means that it can be a little bit easier to resist wear, like UV, weather, all that fun stuff. So coax for hams, what do you care about, right? That's really the question of today is you should get ham radio, you should get coax that matches what you're trying to do with ham radio, right? So if it's just you need coax for in your home and it just needs to be resistant, maybe a little bit UV resistant. You're not going to like direct bury it or anything like that. And you're probably looking for low loss. You probably want to get as much of your power to the antenna as possible. And yeah, what we're going to talk about is some large variations in coax losses. And the losses basically turn into heat. That's RF energy that is no longer making it to the antenna, no longer getting out of your antenna. So losses are a big thing. It's probably one of the most important things to consider when you're talking about coax. But we also want to carry this stuff around. That should be carry, like the name. And thin and flexible might be something that you might want to use. In case in point, RG316. There was a lot of people talking about that in the chat beforehand. We're going to do a little bit of a look at 316 as we get started. I just saw that from Mike. What's up, RadioTube? By the way, guys, if you are having fun or will have fun later in the show, we're not even 10 minutes in yet, consider just having the fun, remain through the rest of the night, and join us on the Ham Radio Crash Course Discord, because we'll be doing an after chat after this where we'll be live again, taking any of your questions live. So questions in the chat, you can keep them coming. I'll come back to it once I get off the slides before we move to the next section, but keep in mind, we're going to be focused on coax. So if you have non-coax related questions, probably want to join us in the after chat, because I'll take all of your questions, or we'll try to take all of your questions live. And again, as already is mentioned, coax is somewhat mostly UV resistant depending on the shielding, and they make tons of options that are direct burial and much more effective of being out in the weather. At frequencies above VHF, though, the length of the run becomes critical regarding losses, which we're going to actually demonstrate with some equipment I have here in the shack. Usually, as frequency goes up, the issues with coax in regards to losses also goes up. So when someone says, just go buy LMR 400, a lot of the reason they're saying that is because it kind of works. It works very well on HF, low loss, and it works good on VHF. And then there's some losses in UHF, but those losses are still much less than the losses that you get with some other stuff like RG8 or, a myriad of the other RGs, right? So that's why LMR 400 gets thrown around a lot. But the problem with that, right, is you got to consider the cost of this, and coax is not cheap. So considering all the types, or focus on more importantly, like what you're going to do with it. What's this coax for? What's it going to feed? Are you going to carry it around? You have to backpack with it. Also, think about going shorter with those runs. Always going to be important. It's very easy for us to say go buy LMR 400, but focus on the numbers, right? So we're going to look at the numbers here in a little bit. But every coax has distinguishing characteristics. Almost every company that makes coax gives you its loss rating on a 100-foot length of said coax. It's going to tell you how much losses there are based off of what frequency you're at. And we can model that not only using calculators online, but we can then take that into something like a nano VNA, which I'm going to demonstrate with that. And we're going to show you how to calculate the attenuation of your length of coax, right? And then once you have that with some simple math, yeah, I'm actually got a calculator out on this one, guys. We're going to be doing a little log work. With a calculator, you can actually determine how much of your out of the radio power is making it through the coax and finally to the antenna. That's something that you can factor in. And it's kind of fun to test some of your coax. And I've got coax of different ages here and quality, and we're going to kind of throw it on the VNA, and we're going to have a little bit of fun. Characteristics of the cables, mentioning the jacketing, weather resistance, UV, all that fun stuff. And then cost. All of this starts getting pretty expensive. Look at that what is that? A DX Engineering 400 Max, which is similar to an LMR 400, 100-foot length. 100 feet of that is $180. Very expensive. Half of that, 50 foot, $109, right? So you should almost just buy the 100 and just cut it in half and re-terminate the ends, right? Model names are also really confusing with Coax, and everybody kind of wants to have like an LMR 400, and so you'll see something like this. This is the 400 Max, to use a term that is something that people, oh yes, 400, that's good, yes, very good. So we'll break down some of the mystery in that as well as we continue on. So what to look for and what to avoid. It's per your budget. I'd start there. Aim for your lowest losses considering what you plan on doing with it, right? That's generally what you're going to say is per your budget, aim for the lowest losses. You want the best materials possible, but you also need to factor in how you might be deploying the coax, because some coax is really rigid and really difficult to bend and deal with, and that may be fine if you're only setting it up once, but if you have to pack it down, pack it in, pack it out every time you go on a Parks on the Air activation, then that might not be so hot. That might not be so good. I include the... what's that? Thank you for supporting us, Russ. The coax is as important as the connector. Not only that, but the coax is kind of like the unsung hero of the shack. Everybody talks about their radio and their antenna, but coax oftentimes gets overlooked and doesn't get the credit it deserves. So we're going to talk a little bit about that, or continue on that discussion. And thanks, Russ, for the support. So yeah, connectors are a big thing, which we're not going to dive too deeply into connectors, but I definitely have my preferences when it comes to that. And then obviously weight and bulk, if considering portable, should be probably pretty high in your list. And weather resistance, right? Weather resistance is going to be pretty high for most, but the connectors come into play again at that time. Now, a note on weight and bulk of portable. A lot of times what we're going to talk about here, you're going to be pretty good from the low frequency HF bands all the way up through 10 meters without picking up a ton of loss. It's when you start getting into VHF, UHF that losses really start to grow on you, and we're going to see it as demonstrated here on my VNA in a second on 316, oddly enough. 316, good for HF, very portable, not so great for UHF. Now, for me, whatever you're doing with coax, if you're going to like leave it up for a little bit of time, I mean more than a couple of days, and it's not designed to be portable, you need to weatherproof it. Water in coax is a massive problem, and once water gets into coax, it's oftentimes very difficult to get it out of coax, particularly if you live in a humid environment. Just imagine if the air is not accepting humidity and your coax is sodden with moisture, then you're not going to be able to draw a lot of that out of it. And there's been many discussions on what is the best way to get moisture out of coaxes, and I don't think there's a uniform standard other than hang it up somewhere and leave it alone. So if it is wet out, it is raining, do your best, at least portable, to cover it so that it's not getting soaked on the connector. And if it's going to be out there for multiple days, or it's going to be your permanent setup, make sure that you hit it with some waterproofing. And I have coax wrap shown here because that's generally what I grab when I'm at the HRO. But there's tons of stuff like this. It's called self-amalgamating tape. You take about 6 to 8 inches of it and you pull tight and torque it around the entire connector, meaning the body of your transformer if you're using an unun, or if you're using some kind of coax adapter or something along those lines. Cover all of it with coax wrap, and then go all the way down that connector onto the shield itself, past the little boot, as best you can. Do that. You need to do that. And trust me, if you do that, you're protecting the cost that you're dropping on potentially a $180 piece of coax. And then once you've done that, and by the way, pull it tight so that it's tightening the coax onto the connector. I don't think I have to, well, I guess I do have to explain this. You don't want to tighten the coax so that it loosens off of the connector. Hopefully that's self-explanatory. Hopefully that makes sense. But yeah, the self-amalgamating tape, you generally need to pull it on there pretty tight. And then use good electrical tape. A lot of guys are throwing 3M in there. Just get good electrical tape. And what you do with the electrical tape is go over the self-amalgamating tape, and that gives you another level of water resistance, weather resistance, because the self-amalgamating tape doesn't really like to be in the sun. and it gets kind of gummy and dirty if you leave it like that. So I hit it with some good electrical tape, give it, about two, a cross layer over the top of each other, hit the whole thing that you just did, and you'll be all right. All right, all right. So a couple tips and tricks for coax to protect it is always coil the coax to avoid kinks. And so what do I mean with that? Do I have a loose piece of coax here? Yeah, this will work fine. So let me go back here for a second. Oh, and there's like what'd you just do? Leave it alone, slides. Don't go anywhere. Anyway, so if you're like, here's your coax, right? Here's your coax, and if you take it and you make a loop, so now I'm holding this loop. Now I want to go backwards the other way. So I'm twisted. Now it's going, it's hard to demonstrate like this, but then now I do another overhand loop, and then I do an underhand loop. Over and under, over and under. And that way, you're never kinking the coax to be looped after loop after loop after loop like a garden hose. You never want that. You want it to oscillate back and forth. Almost like you're making like a spring, not a spring, but like a, what's a good example? I don't know. About 1,000 people have videos on how to wrap coax. So if you do this right, you can literally just take the end of your well-wrapped coax and throw it, and it'll be completely straight, and there's no kinking on it at all. And all my coax, I generally do that after I buy it, is I stretch it out into the, not a slinky, because a slinky goes in a wrapped coil, like a figure eight. There you go, Mary. Perfect term. So again, I'm just going to go like that, and then I'm going to go underneath or underhand, and then overhand, and then underhand like that, right? And then now I've got a non-coiled piece of coax. Please do that to your coax. Please do that to your coax. Treat your coax right. It will appreciate it. Thank you very much. All right. Yeah, if you know anybody that's in the music industry, a roadie, someone who does AV work, they can tell you exactly how to do it if you don't already know how. That's actually a really good tip. Also, KMRD, I believe, has a good video on this. Go watch his video. Highly recommend. I forgot to pull your link up on that one, Mike. Ham Radio 2, but yeah, check it out. Don't put aggressive bends in coax, okay? What does that mean exactly? Well, one, most coax has kind of a bend limit that they accept before it starts damaging the coax, because what is coax? Do I have a good image here that I can show you? I think I do. Yeah, is this going to get bigger? Oh, I know who's got a great image for coax. Where is it? Yeah, buddy. Okay, hold on. We're on Messy's website. Okay, do you see the layers of the coax? There's like a shielding, and then there's like another layer of shielding, and there's like a dielectric, and then there's some interior. It could be a solid core, but a lot of his are stranded cores. Well, if you think about like folding a comforter. If you fold a comforter a couple of times, those layers start to stack up and it starts to squeeze out the side as you're folding it. Well, the same thing kind of happens with coax. You're putting stress when you put that inner radius bend. You're putting stress on the dielectric and the shielding and whatever foil is used. So you definitely don't want to extend. Yeah, somebody's using minimum radius. There's obviously real numbers that go along with coax. The basic idea. Oh, there you go, Mike. Thanks for posting that. He posted a link to his video there. Check that out. You just don't want to really tightly wrap any coax. There are some exceptions. 316 is pretty resilient, but even then, I still just do loops, and then I kind of like will bring the middle together and then wrap it, and then I got like a big, again, a figure eight type look to it. So they're not putting strain on it because you really don't want to strain your coax. Let's see. Let's see. Don't flex it. Yeah, it will fail eventually. All coax will fail eventually if you put a heavy bend in it. Because given enough time, actually Gordo has a couple of short shots he's done on this. The center pin will start to migrate through the thinner dielectric in the bend and touch the shielding. And once that happens, then you've shorted it and you're done. So, and there goes expensive coax. I avoid BOGO ties. This is a personal thing. I only really use these guys. Now I use these Velcro straps, the ones that have the little tag end that you can stick to whatever it is you're affixing to. I use those pretty much everywhere, any cable I get my hands on that I own. I put the Velcros on it. The problem I have with BOGO ties, I really like BOGO ties, and I know they show up a lot in like, I see them all the time at Ham Radio Outlet. I like them, but every time I've used them to permanently like store coax, when I get back to the coax, it's like it's starting to fray, like, degrade, rot, break down. I just, whew, I'm I'm not able to get down on BOGO ties. But so my big thing is Velcro. And by the way, I linked to the Velcro that I use in my Amazon store for today. And then when it comes to, again, putting bends in coax, well, I definitely have an arm that I hang coax off of that's coiled. BOGO or bongo ties. I think it's one and the same. I think you're right. I think it's bongo ties, Jason. Thanks for the correction there. I like to put coax into like it's basically a chameleon bag. I got a couple of bags from Chameleon Antennas that I'll put coils of coax into, and then I'll hang those bags. That way I'm not putting any load on the coax hanging from like a pole in your garage, right, or whatever. That's fine for maybe extension cords, but I'm not going to do that with my coax. It's just too much I just don't want to damage it. I just don't want it to break down over time. Plus, I don't want to put an area in the coax that's not so great while everything else is great, because that could also lead to extensive losses. Have some gear to crimp your own coax runs. This is also a really important thing to do. If you go out and you buy like 100-foot of coax, you only need 75, and let's say you don't get the 75. It's not a great idea to leave 25 feet of anything, particularly VHF, UHF, on the line. You should cut it, terminate it appropriately with a good connector, and then use it in that way. And what's good with that is now you've got 25 feet of other coax that you can use as a jumper. You can cut it down to make 2-foot, 3-foot jumpers, and that'll work fantastic for you. Coax cutters and anything you need to use to strip coax, and even the connectors for good connectors, it's not that expensive, so you should go ahead and do that wherever possible. And then let's see, two more things. I carry a digital multimeter, and the one that I've been carrying, I went to a talk at a ham club recently, and they had a microwave guy, and he was saying how much he loved this guy, this meat meter by meat. Are you focusing, my guy? Yeah, good enough. It is a DMM that has the pokey bit there, but then it also has a coil of wire for the other side. And this thing will do all your continuity checks, all the standard stuff you'd want a DMM to do, but it also do like touchless sensing for outlets and other stuff. Even though it has the 2 leads, it can use just one, which is really nice. And I think it's like stupid cheap. I think it's like $20 or something like that. I could be wrong. Last time I looked, it was like a couple months ago. But yeah, that's been on my list for a little while. So that goes in my bag because it's really cheap and I don't care if I break it. How do you do a 90 corner with LMR 400? You don't. You don't. You don't do an LMR 400. You don't do a 90 corner. You like go slowly. Put a bend in it. Put a strain relief. Hang it down. Do some other stuff. Now, when it comes to coax, there's so many things you can do to actually verify that it's working appropriately. A number of sensing devices like the VNAs, Nano VNA is a really good one. A number of antenna analyzers will do velocity checks or radiometric testing. I'll get to that in a second. We're not there yet, but that is really easy often to make sure you got good coax. And you'd be surprised. You could use a piece of coax for years and years doing POTAs. POTAs is actually, I'm hearing from people, I think Mike's actually mentioned it before too, where, doing POTA enough times, unwinding and rewinding, dragging it through the dirt, whatever, can lead to problems with your coax. And so, yeah, just keep that in mind. Important stuff. And I think that's it. Okay, so what do I want to do with this? So I thought we'd walk through this. So this is Chelegans makes this. This is the SV631 Alpha. It is basically a very big Nano VNA, and it has some features that the Nano VNA doesn't. Like this has a signal generator. We use that for some kind of testing where we generated a tone out of this to see on the receiver side. It's freaking awesome. But we'll get to that in a second. Let's see. Would I consider a standoff when mounting a tower? Yeah, if you can. Sure. I think the standoff also helps you to get that loop that you kind of need in the middle when you have a rotor. So if you think about like Back when I was a kid, growing up in the 80s and 90s, the coolest kid in town was the one that had the BMX bike with the detangler so that he could turn his handlebars over and over again. Well, we don't have detanglers for Coax, right? So we've got to add a loop that has enough slack that can rotate in turn with the rotor and not go beyond and again damage the coax. So standoff with the appropriate way of handling that free coax space or that free loop of coax. Good stuff. Good stuff. All right. Let's see.
And 9.
Was that playing the whole time? Or did that just happen while I was talking? Oh, anyway, I want to go give a shout out because I got a good. So this channel, West Texas Video Gates, he did this video on watts through coax with dB value to data sheets. This is really, really nice. So if you got your general license, you at that time learned what the algorithm was to do a dB to power relationship, and it uses the logarithmic function on a calculator, which we'll demonstrate here in a little bit. But that was really, really, it's a handy tool if you want to kind of decode some of these data sheets from the coax manufacturers. So we'll take a look. Yeah, I did. Yeah, it's part of your general test. It truly is. So let's see. Where's the next one? All right. Big shout out to him. Where's the okay? So what do I want to do? There's a couple of ways to go here. Let's pull up the calculator. Let's pull up our calculator. Okay. So this is the everyman information gathering tool. This comes from kv5r.com. He's got a number of really cool little websites you can check out. RF feed line, coax, and ladder line loss, and ERP calculators. So if you scroll down here, right, so let's go to line loss calculator, and let's just take, I don't know, some bog standard RG8, right? So here's some RG8, and we got a 100-foot length, which is crazy long. 100 feet is actually pretty long. And let's just do 14 megahertz, and let me embiggen this for you guys, right? Because we're talking losses. We want to make sure all of our power is getting through that hose, that RF hose we call coax. So what does that turn out to? Okay, it is a loss of 0.662 and a total loss once you factor in SWR, because like I say, so if we made this 0, watch it drops it down, no SWR, so you just get straight coax loss. 0.662 dB of loss. Well, at the end of the coax where it touches the antenna, just 0.66 dB of loss means we're only putting out 85.865 watts at the other end of the coax where it goes into the antenna. So you've already lost 15 watts right off of the top of whatever you were doing with your 100-watt radio. So that's when people are like, well, I need a Yagi. Now I got 6 dB to add back onto that, that whole thing. But that's RG8. So you're like, okay, RG8's kind of cheap. Yeah, let's throw 1,000 watts behind that. Let's see what happens. Wait. I just made it 1,000 feet. Don't do that. Let's do power in. I'm like, wait a second. Yeah, so look at that. 858. If you put 1,000 watts through it, only 858 is going to make it with the 14%. And the 14% scales. I could have just did the math, but whatever. Okay. So let's go down the list, and not all the coax is here. So RG316 is not here, but I'm going to show you that first on the demonstrator. Let's see. Let's just do LMR 400 to just get it out of the way. So if you go to LMR 400, yeah, there's LMR 400. So 100 feet, power end is going to be 100. Stop it and calculate. So we're going from a 0.66 to a 0.45. Which means you're only losing 10% power, and so you're getting 90 out. So 4% better, or 5%, sorry, 5 watts better, 4% better on total throughput by paying more and going with LMR 400, right? Let's do another one. Oh, they've got Heliax in here. Let's go with half-inch Heliax. Let's just see. So even if you went half-inch Heliax, you'd only get 5 more watts output on the other end. Something to think about. Let me go back up and do 240. LMR 240 is really good stuff too. I like LMR 240. Not that one, 240. There we go. And do the calc. So that's worse, 19% loss. And that's some thin stuff. I've got some of that too. You want to do RG 214? Okay, I'll do RG 214. Is it there? It's not there. Oh, wait, is it there? No, it's not there. Unless I'm missing it. Anyway, doesn't matter. Yeah, so Rick, now, okay, now, so, all right. Okay, so Rick, now this is where we want to hit this point. So that was against 20 meters, 14 megahertz. And what did I say earlier in this? That as you add frequency, as you go higher in frequency, your losses get real bad, real fast. So let's go back to our friend RG8, and we're going to change the frequency to one, I don't know. What do we want to do? Let's do 440. No. Do I want to do 146? We'll do 146. So one VHF, right? VHF. Here we go. 42% power loss. Oh my God. So that from 100 watts to 58 watts out. Same wire, same coax, right? So let's do 440 now. So now you're talking UHF. You ready for this? Shocking. 64% power loss. 35 watts out. Ouch. That's bad. So let's change it to LMR 400, and we'll do a quick look at that one. 400. Go back down to 146. So 29%. Power output 70 watts. Way better. 20 watts better. Way better. And yes, coax do get hot. The losses are expressed in heat. Wait. Yeah, so that's 146. So 440. Here we go. Still only getting 50 watts out of LMR 400 on 440 at 100 watts. Pretty bad. UHF 440, 440 megahertz, 70 centimeters. When you start getting higher and higher, lots of losses, lots of heat. Good question, Eric. I don't know that. But yeah, it's going to get hot. And sure, you'll probably lose some of it out of the jacket, the connector. Connectors play into this, so using an appropriate connector, what does our book tell us if we paid attention in class, kids? If you're using a PL239, then you will only be good up to past VHF, and at some point you have to go to a Type N connector. A Type N connector is going to do a lot better for higher frequency. But okay, let's look at this in a different way. So we're gonna get into the weeds a little bit here. Yeah, we can come back to the stuff, but let's have a little bit of fun on the desktop. Okay, so I have a piece of RG316, and so first we got to determine what the length of this thing is. So we're gonna do that, and then I'm gonna show you how to do the losses that are characteristic of this piece of coax. So we're not going to be able to fantasize about future pieces, but I got two runs of 316 here that we might be able to extend this into. Looking at what 100 watts might look like, okay? Okay, let's have some fun. All right, so let's get my coax out of the way here for a second. So I have a random piece of 316 that I pulled out of my Poto bag or something. So here's this. Right, so a VNA allows us to do a single port or multi-port test. A single port's what you're going to use for like testing an antenna. Or in this case, we're going to do something called TDR. So where's our TDR? Yeah. Can you see that? Yeah, you can see it. I just can't see it very well now. So this is saying that the point where that reflection is the end of the connector. That's the open hole. And that we're roughly 3.13 meters long, this coax. Okay, so about 10 feet-ish or more of coax. All right, cool. So 10 feet of 316. I'm going to now go off of TDR. Now I'm back to my through test. And we're showing at 10 feet of cable, 10 feet. At 440, it's a 1.93 dB of attenuation. How do I get you to focus there? Come on, buddy. Come on down. There we go. So 440, 1.93. 148, that's as close as I could get to 146, is 1.14 dB negative, right? So let's factor that into power. So what if so let's get our calculator out here. Yeah, we got to do that. So we're going to go second log, and we're going to go negative 1.93 over 10. So that's a 0.64. So if we multiply that by, say, 50 watts for any UHF radio, we're getting 32 watts out on this, on 50 feet. If this was 100 feet, this would be crazy. Vince, you laugh, but this calculator is the bomb. You go look up any reviews on this calculator. Go look up how much it costs and what it does. You shut your mouth when you're talking about my calculator. All right, so that's 50 feet of 316 at a 10-foot length of coax, right? Well, what's that big old coil you see in the background? So the coil is 50 feet of 316. So I'm going to plug that in, and then you should really see something happen. So let's do our TDR on this one. Buddy. Come on. All right, so now we got the only thing this doesn't, I don't know how to do this yet, is get to. Oh, come on. There we go. I know there's a way to fast scroll to it. So about 15 meters. 15 meters length of coax is what we've got here. So this is roughly 50 feet. All right. Now, turn that off. Now I'm going to plug this in for the through test. Wee doggy. So it's a negative 9 dB on 440. Which, again, guys, if you look at, so let's look at 10 meters, 1.8. That's still pretty high. But if you go down to 14.8, that's not so bad. And lower frequency down to 40 meters is totally fine at 0.15. But let's just stick with this one. Negative 9. Give it a 9er. So we're going to go negative 9.08 over 10. Times 12% times 50. It's just 6 watts. Not good. That's not good. That's not good at all, right? Yeah. A 9er? Did I hear a 9er? Yes, you did, sir. You heard a 9er. So, okay, this is my trying to attempt to demonstrate what these characteristic losses look like. And 316, again, I use 316 all the time. I don't generally use it on 10 meters, though. I generally use it on 14, 40 for sure. I love it on 40. But I don't go much higher than that, right? And I think a lot of you do as well. So, okay, well, what do we do? Well, I've got some other cables here that we're going to do a quick test with, and we're going to check and see if characteristically they kind of line up with what we expect. Now, I don't have the numbers for all of these because, again, remember the manufacturers will oftentimes give you the losses over 100 feet, which for us, a lot of times we need more like, I need 20 feet, I need 30 feet losses test here. So, it happens. But let's grab another fun one. I got 240 here. And I got that PotaFlex 6 and 7. Don't worry, we're gonna look at that too. But yeah, let's go back over here. All right, so that was my BNC part of the show. So let me get this guy out of here for a second. Also in my Amazon store is my favorite little box of Coax Swiss Army knife adapters. So let's get our BNC out of here. So these connectors are Type N, and then right now they're BNC, and they have these little threaded ends. And when you're calibrating VNAs, you calibrate out this stuff. So that was done beforehand. So I'm going to go get rid of our BNC. We're going to go to our SO239. Oh, come on, don't cross-thread these. This is good stuff here. Come on, bud. All right, so now we got our better connect. Well, not better, but you know. What's my Oh, I'm not a very good transmission line, guys. Just heads up. Can I isolate myself to just the pin? Will that help? 30 dB of loss. Whew. That's trash. All right, so I've got some 240. I actually don't know what the length of this is. So we're gonna do our test here. CDR test. Time delta refractometry, I believe. Come on, dude. Okay, about 7 meters, so not very long. All right. Now we got to connect the other end. I was looking at that like, what the heck just happened to my coax? So 7 meters of this stuff, not bad. Not bad for HF. 10 meters in particular, that's totally usable, -2. The other side's fine. But 1.92 at 7 meters, so 25 feet-ish. So we're going to go back to log -193 over 10. So 64% times 100. 64 watt output. Bazinga. Not great on UHF. Right? 1.92 dB loss in the form of attenuation of the coax. This VNA was not cheap. I'll just say that right up front. Okay. Let's do some maths here. Hold on. We might as well do this right. If I'm going through this, I might as well not recreate this all over again. So let's go over to the web here. What did we just do? LMR 240? 240. And 340. Are you upgrading? God, I can type. So we need... So this was 7 meters. And it's going to be... We'll go 7 megahertz, 14-ish, 28, 146. Stop it. 146 and 440. I'm not going to do this for all of them, but I'm just doing proof of concept. So this is -198. And -110. I'm not going to make you watch me do the science-y nerd stuff in the background. It'd be nice if I did this right where it should be. .32. Oh, dang. All right, good enough. All right, so let's hop over to the ones we actually care about. What time we got? Oh yeah, let's do this with the last 15 minutes. The cable does not attenuate it. No, the cable. Yeah, good point. There's no. Yeah, don't no problem there, guys. Otherwise, this video would take a very long time. And thank you, Mike, for having my back in the chats there. Tell me if you like my calculator, Mike. You gonna go buy one of these bad boys? Highly recommended, though. I'm not kidding. Go look up the price of it. It's like nuts. All right. Now, Grayman, coiling it can add impedance on the outer jacket. That's kind of how an ugly balun works, but it's not going to mess with the characteristic impedance or losses of the coax. All right, let's just jump into our... Oh, yeah. Oh, yeah. There's my one of my... How many coax? What is this? Oh, there's a jumper in here? Hold on, I got too much coax. Where's the second run coming from? Well, we'll deal... Oh, it was a jumper. There's a jumper. Okay, let's get a run of how long this is. Oh, yeah, this is going to be a longer boy. So about 16 meters of LMR 400, and this is LMR 400 that has the inline ferrite. So let me write that down. Okay, now we got to get this crazy end up here. Okay, there's the inline ferrite. The inline ferrets. Always make sure you have ferrets on your coax. And... Ooh! So look at that. Negative... There you go. Negative 2.85. Wow. So I'm going to leave that here, and I'm going to write all this down while you guys look at it. 284 on UHF, negative 1.44 on VHF, negative 0.32 on 28 megahertz, 30 on 14, and 7 is 0.75, 73. Okay. So there's that. All right, let's get this guy out of here. This coil is so... Okay, that's a problem. That's a problem for me after the stream. Hold on. Let's get it out of here. All right, we're going to go POTA 6. Now, why... POTA 6 obviously is much more flexible and usable than LMR 400 in the field. So this is nice to carry. We use this with the Buddy Hex. Actually, we use this with a number of antennas over the weekend. You could argue that the connectors are better too. I don't think anybody's going to argue with that. All right. So 16 meters, about pretty close. Yeah, 16 meters for POTA 6. So we're looking at the same type of wire here, guys. Same links. Now, I will note that I'm not changing. I didn't mess with the velocity factor, and that's usually a factor of this this TDR test. So the links will be slightly off in some cases, but it's not enough for me to get that upset about because all the coax we're working with right now is supposed to be the same. Okay. So you're getting, let's see, POTA 6 is negative 3.1715 on UHF, negative 1.78 on VHF. It is negative 0.5 on 28 megahertz, 10 meters, 0.15 on 14, and 0.56 on 40. So behavior pretty much is similar No, I take that back. LMR 400's better on 28, but they're kind of close on the lower bands. Okay, now, don't get upset. The 6 is way more portable friendly than the 7. I still use the 6 most of the time. TDR automatically figures that out. It goes to where the well, I know that marker. I haven't figured out how to do it yet, but I know that marker can go to wherever the peak is, and the peak is where the reflection's at. I don't know how to do it yet though, so I'm just going with the manual method. Also, I know what the length of all this coax is. I'm not doing it because I don't know the length of the coax. I'm doing it just to say, hey, yeah, this is what it reads out to. But yeah, good question. All right. Slightly more rigid, the 7. And we'll do a physical comparison against these in a second. I'll show off what they look like. Get the 7 all up ins here. Hey, buddy. Now, I'm guessing when I hit TDR here... Oh, what happened there? Oh, I thought this was the same length. It's not. That's probably a factor of the velocity. I'm pretty sure that's a factor of the velocity because these measure out to... They're all 25 feet. So we'll leave that alone for a second. So this is the Potaflex 7. Okay. Hey, now. That's pretty good. All right, I'm going to track the numbers here, and then I'm going to show you what we ended up with. So 0.69, 0.32, negative 0.32, negative 1.29, and negative 2.23. Now, now it makes me wonder that I need to go measure this coax length. I may have to go measure this. I'm not doing it now, but that is an interesting factoid that the TDR was so off. I wouldn't have expected the velocity factor to be that off, but we might be able to look at the messy website, the M&P site. It's not a messy site. I mean, you know, Messy's site. You catch what I mean. Hold on. Make my numbers embiggened a little bit here. All right. So how'd we do? All right. So Potaflex 7 was still behind LMR 400, but not that bad. And considering the difference between the two cables, this happens to be the same diameter of cable, so I'm going to put them together in the shot here in a second, and then I'll grab the 6. Yeah, Hammett till it hurts. Connector loss is almost non. It's not much to worry about. Now it is something to worry about when you get to super high frequency. If you're talking microwaves and stuff, yeah, then it's vital. Then it's really important. But at 440, what we're testing for, that's not that big a deal. So yeah, you can see the numbers. LMR 400 is pretty much better, but it's also a much more rigid cable. Heavier, more rigid. I'm still taking all the Potaflex stuff out every time I go portable, so keep that in mind. But yeah, for comparison, let me throw back over the overhead here. So the cables. So just comparison between the two. So that's LMR on the right, and that's Potaflex 7 on the left. Different kind of animal when it comes to ease of use and carry. Come on now. Stop moving. There you go. That's about as good as it's going to get. Right? I think so. Let's see. Go back to the Yes, LMR. Well, so the 6 is. Well, let me get the 6 too, so you guys can see it for comparison. The 6 is the most flexible. 6 is awesome. I really like the 6. It is what I use almost all the time now. It is way more flexible. N0 LSD. So what I'll end up doing is I will finish fleshing this out on my own time when I've got the time. And then I'll post it to Patreon or something. All right. So, any questions before we start wrapping things up to head over to the after chat? Reminder: after chat, you join me on the Discord. I'll take any of your questions, any of your ham radio questions. Oh my gosh, I missed a super chat. Ah, dog. Oh, look at the doggy. Look at the doggo. Thank you, buddy. I appreciate that. Appreciate you sending me a super chat. So anybody say question or at Ham Radio Crash Course, and I'll try and do my best with the last couple of minutes we have here. In fact, I'll probably do that as we hit up our Patreon crawl. New Patreon crawl for all my new Patreons in both April and May, because patron picks this month. Today is a catch up from last month because I traveled so much in the month of April. I was gone every weekend except for the first weekend of the month. It's a crazy weekend. So thank you guys. I appreciate that. Would LMR 400 be similar to KMR? See, that's the thing. So you got to have to pull up both the sheets and compare them against each other. You got to compare them against. So the point of all this was that you go look up the numbers. Don't just take it for saying 400. Oh, that's got to be the same as LMR 400. Not necessarily. Also, it may have attributes that you like better. It might be more portable. It might be more flexible. It might be better to bury in the ground, So keep that in mind. I have 50-foot Potaflex for portable. Thought ham radio wilderness was... There you go. That's a good one. Oh, there you go. He's got that KMR, the KMERD 400. No, you use your DMM for that. So, when we're done here, I'll show you how to do that. But break out your little meek boy, set it to DC ohms, and do a test. Just toot toot both ends. So, set it to ohms. Yeah, and it's auto sensing, so it'll do it. I'll do that when we're done here. Oh, so something like a flexible LMR 400 is good jumper cables. That's what I use. But I've used much cheaper. Jumpers because, again, the length is not that bad. Very short length. You can get away with a little bit lossier coax. But, again, you want to keep it all the same. So, okay, let's fold back here for a second, and I'll show you what this looks like. So, where's the... This is a jumper, so I'm just going to use this, I think. Yeah. Okay, so we got the two leads are right here. So if you... You see that? You don't see that. You don't see that. Live multimeter work. So we're touching the pin. Come on, duder. Stop running away from me. Oh my God. You just gave me the number. What's your problem? It just read out 50. Don't make it auto, just... I need another beer to make this work, apparently. Okay, let's do the shield. This is all over the place. What is it doing? Come on, dude. Well, I can tell you it is 50 because it just displayed 50 for like a second. It was doing that earlier, but I think I got it stuck in some kind of auto mode. Anyway, it's 50 ohms. It's 50 ohm coax. All right, that'll do it. Good Lord. By the way, everybody who has questions and you waited to this last moment, join us on the after chat and you can ask, but I'll take this last one. This is it. This is the last one. Would the Potaflex Big 6 be too heavy to use for a dipole or off-center fed up on a 10-meter portable mass? No. Oh, like a DX Commander? It would depend. You wouldn't be able to use probably the tippity top elements. As long as you had the mast guide well, it'd probably be okay. It'd be fine. It'd be fine. Some of the more thin top sections might be difficult, but yeah, cool. All right, everybody, that'll do it. Hopefully this gives you the idea. Go look up. So if you're going to go buy DX Engineering 400, again, nothing wrong with that, but look the numbers up. If you want times microwave numbers, go get those times microwave numbers. LMR 400, look that stuff up. Messi and Poloni, look it up. And then you have a better idea, hopefully now, through this talk, of what that all means. You can do the log function, I promise. It's not that bad, particularly if you follow the video that I linked. Not my video, another really good YouTuber's video. He deserves more vids, so go give him some love. All right, guys, thank you so much. Cheers. I'll see you in the after chat in a little bit. We'll be talking about probably some Mesh-tastic stuff, I think, but we'll see. 73. Oh, yeah, ABR for sure. All the LMR 400 you saw on the table is from ABR.